Dear students, welcome to Eazy Btech, your guide for Btech and beyond. Here I am going to teach the subject Signals and Systems. And today's session, we are going to discuss elementary signals. Before going to our session, please subscribe, share the channel to your friends. It is very helpful to you. So please subscribe, share the channel. Let's start our session. Today's topic, elementary signals. And before going to this topic, we are going to discuss a small topic, multiple transformations of independent variable. The topic name, multiple transformations of independent variable. Multiple transformations of independent variable. Independent variable. So this topic, a small topic, after discussing this, we go to elementary signals, discussion of elementary signals. As I told you already, independent variable is time. So multiple transformations means, for example, consider a continuous time signal x of t. We are taking a continuous time signal x of t. Continuous time signal x of t. Now, multiple transformations of independent variable means we are going to do multiple transformations of independent variable means that may involve time shifting, time scaling and time reversal. All the operations we are doing on this x of t. So x of t is a continuous time signal. Multiple transformations of x of t is like x of alpha t plus beta. So this is called multiple transformations of independent variable. Because if you observe this, here beta is time shift. And alpha t, this indicates scaling. Time scaling. So two operations are involved now. That is why multiple transformation or multiple transformations. So how to perform this? How to do this? Alpha t plus beta we have. So first I will take x of t. Then I am going to do time shift operation. First I am performing time shifting operation or time shift. Then it will become x of t plus b. Now after time shifting operation, we are doing time scaling operation by factor alpha because we want x of alpha t plus beta. So now time scaling operation by the factor alpha. That means wherever you have t, it is now alpha t. The t is replaced by alpha t. So the result we get is x of alpha t plus beta. So this is the order of performing x of alpha t plus beta. First time shifting operation, then time scaling operation, we get the result x of alpha t plus beta. For example, if we have minus polarity or minus sign, x of alpha t minus beta. So here we take original signal, then we perform time shift operation minus sign means it is right shift. After time shift operation, we perform again time scaling operation, that is alpha t. Then we get the result alpha t minus beta, x of alpha t minus beta. So we perform this multiple transformation of independent variable by taking an example. Let's take an example. I am taking a rectangular pulse. X-axis is time and the y-axis is x of t. Let's consider x of t is a rectangular pulse or rectangular signal. Its amplitude is, for example, 4, and it is from -2 to +2. This is the signal we are considering as x of t. Now the question is, draw x of 2t plus 3. This is the question. We have to plot x of 2t plus 3. So, as our procedure, first we do time shifting, then we do time scaling. So now I am taking x of t, do time shifting. So here time shifting means we can do right shift, we can do left shift. Here the plus symbol indicates left shift of the signal. We are going to shift the x of t 3 units left. X of t shift left side 3 units. That means -2. Again 3 units left side. 3 units left. So it will become -5 and +2, 3 units left side, it will become -1. Now the signal is between -5 and -1. So I am going to plot it as it is. The signal is between -5 and -1. So amplitude is the same. How much is the amplitude? 4. So amplitude no changes. Here I am taking 0 y-axis. So this is called x of t plus 3. Time shifting is completed. X of t plus 3 is obtained. Now we are going to do time scaling. How much factor? What is the time scaling factor here? 2. Time scaling by factor 2. Then we get the result x of 2t plus 3. Here scaling factor is 2. Scaling factor is 2. So scaling factor is 2 means it is more than 1. So signal compressed. Signal is compressed by factor 2. Compressed by factor 2. By the factor 2. So how to plot the signal compressed by factor 2? We need to divide the time instants by 2. That is meaning of signal compression, right or not? So here -5 by 2. -2.5. minus 5 by 2, it will become minus 2.5, and minus 1 by 2, minus 0.5, minus 0.5. Now this is the resultant signal, final output. So the amplitude is same, no changes. Now this signal is x of 2t plus 3. So this is a way of performing multiple operations on independent variable. So here time shifting is there and time scaling is also there. Okay, so it is clear. Now we are going to see elementary signals. We are going to see elementary signals. Very, very important topic. Elementary signals. So what actually meaning of elementary signals? These are input signals. What is the use of elementary signals? They are used as input signals. Input signals for checking performance of systems. For checking performance of systems. Performance of systems. Systems. So to check the performance of systems, we need input signals. That input signals, elementary signals. We have continuous time elementary signals, continuous time elementary signals, discrete time elementary signals. Continuous time elementary signals, and the second, discrete time elementary signals. Discrete time elementary signals. Okay, so we are going to study first continuous time elementary signals. We are going to discuss about continuous time elementary signals. Okay, now continuous time elementary signals. The first one in this, unit impulse function. Unit impulse function. This is the first continuous time elementary signal, unit impulse function. In this subject, in this signals and systems, function or signal, we can call function or signal. So don't get confused. Signal, function, both are same. Unit impulse function. It is also called Dirac delta function. Dirac delta function. And it is represented by mathematically del of t. Del of t. And if you see the signal, it is like the signal is, I am plotting x-axis time. Now this impulse, unit impulse, exists or only defined at t is equal to 0. this impulse is only at t is equal to 0. So this is the impulse function del of t. It exists only at t is equal to 0, right? And the amplitude of the impulse at t is equal to 0 is infinity. This signal is up to infinity. And t is not equal to 0, like t is equal to 1, t is equal to 2, t is equal to 3, or t equal to minus 1, minus 2. This del of t or impulse function is 0. It not exist at t equal to 1, t equal to 2. So that is impulse function. So I am writing now mathematical definition. Del of t is equal to infinity at t is equal to 0. At t is equal to 0. And del of t is equal to 0. T is not equal to 0. T is not equal to 0. This is the simple definition of impulse function. Now, unit impulse function. Unit impulse function means this is the first point. Del of t is infinity at t is equal to 0 and is equal to 0. T is not equal to 0. Now, the area under impulse. Area means integration minus infinity to plus infinity. Whose area under impulse means del of t dt is equal to 1. Is equal to 1. This is called area under impulse. Is always 1. Area under impulse is always 1. We can also call area or strength. Strength. Strength of impulse is 1. Okay. This is the impulse function. For example, if you want to plot or draw del of t plus 2, it is del of t. It is del of t. This is del of t. Now we want to plot del of t plus 2 means the impulse signal del of t shifted left 2 units. It is time shifting of del of t. Time shifting of del of t. Here plus symbol left shift. Here 2 units left shift. That's simple. Minus 2. So at minus 2 we need to plot impulse. Now this will become del of t plus 2. And we can also do right shift of the impulse. For example, if you want to draw del of t minus 3. This is minus sign, right shift, 3 units right shift. Whose right shift? Del of t right shift, impulse right shift. So I am plotting that 3. At 3 it is present. Now this will become del of t minus 3. Del of t minus 3. Okay. How to write mathematically this del of t minus 3? Del of t minus 3 is equal to infinity only at t is equal to 3. Right or not? At 3 we have impulse. Impulse amplitude is infinity. Amplitude is infinity. and del of t minus 3 is 0, t is not equal to 3. This is a definition, mathematical way of writing, right? Area under impulse is always 1. But here one point I want to mention. The lower and upper limits, here minus infinity, upper limit is plus infinity, and the impulse is at t is equal to 0. So what this is saying, the area under impulse is g is equal to 1 if and only if the impulse is between lower and upper limits. Is between lower and upper limits. The impulse must be between lower and upper limits, then only the area under impulse will become 1 or unity. And one more point I want to mention, one more point. For example, 2 del of t. The meaning of 2 del of t. Here, the del of t is an impulse function. What about 2? Number 2 indicates what? This 2 indicates area of the impulse or area under impulse. Not amplitude. Area under impulse is 2. The 2 indicates area under impulse. Strength of the impulse is 2 or area under impulse is 2. So this is the point I want to mention here. Okay. This is about impulse function. Unit impulse. Area is 1. Next I am going to see, we are going to see unit step function. Second one, I think it is unit step function. Unit step function. Unit step function. So it is represented mathematically as u of t. So if you see u of t, it is unit step function. Now I am plotting this signal. How u of t is. So here x-axis t and y-axis is u of t. So this is unit step function. It is like step shape. This is unit step function. So here amplitude is clearly 1. This is 0. So this is the unit step function. If you see the definition of u of t, mathematical definition of u of t. See, u of t is equal to 1 for t greater than 0. This is t greater than 0. U of t is 1. T greater than 0. And same u of t is 0. It is 0 for t less than 0. This is t less than 0. U of t signal is 0. At t is equal to 0, what is the situation? See the arrow. At t is equal to 0, what is happening? It is changing from, suddenly changing from t is equal to 0, no time, suddenly changing from 0 to 1. So that sudden change is called, this line sudden change is called discontinuity or discontinuous. So u of t at t is equal to 0, at t is equal to 0, u of t is discontinuous. It is discontinuous. So this is the definition of unit step function. So unit step means amplitude is clearly 1. For example, if it is not 1, amplitude is not 1, then we call as step function. Then we call as step function. Why it is called unit step function? Because amplitude of u of t is 1. Clearly it is 1. So unit step function. If not equal to 1, we call step signal or step function. Now, shifting of u of t. Suppose I want to plot u of t minus 2 and I want to plot u of minus t. I want to plot u of t plus 1. This is folding, this is left shift, and this is folding, and this is right shift. So let's see one by one. So this is the original signal u of t, right? U of t minus 2 means the step signal shifted right. How many units? 2 units. So how many units it is shifted right? 2 units. So from 2, draw step signal. This is a step signal shifted right by 2 units. This is 0. And this signal is now u of t minus 2. Amplitude is 1 only. The amplitude is 1. And similarly, u of minus t, folding of u of t. This is folding of u of t. So this is u of t. Do now folding. So I am doing folding. This is the folding. Folding of u of t will become u of minus t. This is u of minus t. So amplitude is 1 only. Now observe, this is folding of u of t, u of minus t. Means the signal which is on positive side, that will appear at negative side, and the signal what is on negative side will appear on positive side. So here 0, here 1. Next, u of t plus 1 means left shift of step signal 1 unit. Left shift. Now the signal is shifted left. Minus 1. Here we have 0. So amplitude is 1 only. So now step signal is shifted left by 1 unit. Okay. Now I am going to write important relation between unit step function and unit impulse function. How they are related? Relation between u of t and del of t. U of t and del of t. So very, very important relation. D by dt of u of t. Differentiation of step, unit step. That gives the result del of t, unit impulse. Differentiation of step signal is unit impulse, or integration of impulse. Integration of impulse. Minus infinite to t limits. So integral minus infinite to t del of tau d tau, del of tau d tau is equal to step signal, unit step signal u of t. Very, very important relations. So both are same. The relation between unit step signal and unit impulse. Integration of impulse will give you step signal. Differentiation of step is equal to impulse function. Okay. So two continuous time elementary signals we discussed: unit impulse, unit step function. Okay. So still we have elementary signals that we can see in the next session. Thank you. Thank you all. And all of you, please subscribe Eazy Btech channel. Thank you. Thank you all.